Hello students, it's the beginning of the session for CBSE, ICSE, and already Bengal board has covered 4 months, but almost three of the boards, they have similar kind of chapters in the preliminary part. I already discussed motion, its graphical analysis in my previous videos. Here also, since it's the onset, here also I am going to discuss motion and the analysis how you do when it comes to numerical problems regarding speed, velocity, average velocity, displacement, distance. All these are very you can say just the preliminary parts of motion. Okay, today I am going to discuss these parts, and to keep in mind that it is not fixed to some board. If you are following CBSE or you are following ICSE, both the students are going to really get a clear insight of the topics. So let's start. Okay, so as you already know that what is distance and what is displacement. We have a question from NCERT class 9 book, and if you are following this, you are having ample time to write it down. Please write it down, for that is going to help you later. Now the matter is, you already know distance and displacement. You know distance is the length of the path, or you can say the length of the path traversed or traveled, and displacement is the shortest distance. Okay, it is the shortest distance between the starting and the ending point. Okay, so how you actually depict it? We depict it like this, that suppose if some particle is moving from point A to point B, then that particle actually it can move from A to B in several paths. How it will move? It can move from A to B along path C. It can move like this along path D. It can move like this along path E. I mean to say, it can be ACD, ACB, ADB, AEB, whatever path. So all these are different. You see, this is different, this is different, this is different, but there is only one length which can never be different, from A to B along a straight line path. So the path length from A to B differs in this case, this case, this case, and it can be innumerable paths. Suppose you are going from your home to school, there can be different paths by which you can move from A to B, that is your home to school. But there is only one straight line path, and that is the shortest length, and you term this as displacement. I know it is there in your book. Still, before starting the question, I thought of completely making you understand. So all these are distances, and distances can be many. Whatever it is, distances can be many, but displacement can be only one. And displacement is a vector quantity which has its direction from the initial to the final position. So whenever you are calculating displacement, think about what is the initial and think about what is the final position. Okay, and then you have to have a straight line drawn between the two to calculate the displacement. All right, so let's proceed for the question. Here you see an athlete completes one round of circular track of diameter 200 meter in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? It is quite an easy problem, but to some students it may seem to be difficult when it comes to calculation of displacement. First of all, one round of circular track of diameter. When diameter is given, what you do is you calculate the radius, as I have done. You see, The radius calculated is 200 by 2, that is 100 meter. And then you calculate the circumference, which is 2 pi r, and you keep it like that. Don't do any kind of calculations beyond this, because that will come up to a decimal value, which may confuse you. Now, this athlete completes one round of the circular track for in 40 seconds. Okay, so the distance covered in 40 seconds will be how much? The distance covered, the circumference is 2 pi r. It is the distance covered for one round, and one round takes 40 seconds. Now the distance covered in 40 seconds is 2 pi r. So in 1 second it will be 2 pi r by 40. And then the distance covered in 140 seconds, because they asked you for 2 minutes 20 seconds, which I simplified. The minute is converted into second after multiplication of 60. So 2 into 60 plus 20 gives you 140. So in 140 seconds it will be how much? It will be 2200 meters. So this is the distance covered. So this part is going to be easy for you. Now the part that you have to now think about is the displacement. For that, just imagine what is the time given to you. The time given to you is 140 seconds. And you know, to complete one round, it is only 40 seconds required to complete one round. All right. So let us first find out this 140 second is actually, if you want to find it out like that, this 140 seconds, you can break it up like this. It is actually 120 plus 20. So can I write 120 as 40 into 3 plus 20 seconds? See, you can do it. Okay. Why have I written it as 40 into 3? I find 120, it is the multiple of 40. And 40 seconds was the time taken to have a complete round. So you have to determine in this 140 seconds how many times the athlete went round the circular track. So you find how many times? 3 times. That means the athlete who completed this circular track 3 times, then also he moved for 20 more seconds. So if for one complete round you take 40 seconds, then for the next 20 rounds you will suppose say half of it. You will start from here and finish it here. I mean to say that when you are having the time, you have to ascertain in that time how many rounds he went. And you know that displacement for an object who starts from here and again ends here is 0. But the athlete, after completing 3 rounds, I mean to say 1, 2 and 3, in these 3 rounds the displacement was 0. Net displacement was 0. But then there were 20 more seconds when he was running, and if in 40 seconds he goes complete distance, then in 20 seconds he'll go half the distance. I think I'm clear. That means the athlete after 3 rounds, okay, 1 round is 40 seconds, so 3 rounds is 120 seconds, then another 20 seconds it moves from here to here. So the initial point is here and the final point is here. And then what is this distance? This is the diameter. What do I mean to say? I mean to say that in this 40 into 3, that means 3 rounds of the circular track, the displacement will be 0, because athlete starts here, completes 1 round, so the initial final position is same. So, but after the 3 rounds, again in the next 20 seconds, he reached here, which means this is the initial, this is the final position. whatever may be the distance covered, his distance covered was 2200 meters. The athlete, to find out his displacement, we have to calculate the distance covered, the shortest distance covered in this next 20 seconds. And the initial position being this point and final position being this point, this is the displacement. Okay? Then what is this displacement? This displacement is the diameter of the circular track. Okay? So the displacement, that is how you'll write the displacement equal to diameter of the circular track Why the diameter? Because if he takes 40 seconds to go round this complete circular track, then he will require these 20 seconds to go half the length. Half the length traversed means displacement is from here to here, straight line, and this is the diameter of the circular track. I think it's clear. So you can directly write 200 meters. That is the displacement. I think this question is clear to you. That will also help you to find out the other problems regarding displacement. There will be other problems when you will be said that some object is thrown upwards. Okay, it reaches its greatest height, suppose h, and then again comes back, okay, to the ground. So when it reaches high and then again comes down, the total distance will be h up and then h down. That is h plus h, distance is 2h. But where it started, it went up and came there again. So the initial and the final position being at the same point, the displacement will be 0. Okay, such questions you are going to definitely see. This question, this particular question can be made a little bit different if it happens that the time is changed. Whenever the time is changed, always try to find out the circular track which took 40 seconds to get completed. How many times it was actually moved. Okay, how many times the person moved along the circular track in the circular path, and then when it ended. Here it was 20 seconds more, so it came here. If it would have been 10 seconds, then it would come here. Then the displacement would be this. Okay, so it's again a separate question that we can discuss later. If you have any queries, any questions regarding distance and displacement problems, you can write to me.